Welcome to the world of classification in machine learning. Here we explore how machines learn to make decisions just like humans do. Understanding these concepts can help you build smart systems that solve real-world problems. Let's dive in. Let's explore the different types of classification. First, we have binary classification, which is used to categorize data into two distinct groups like spam or not spam. Next is multiclass classification, where we assign data to one of three or more classes, such as classifying different types of animals. Lastly, we have multi-label classification, where each piece of data can belong to multiple classes at the same time, like tagging images with relevant labels. Let's look at an example of binary classification. In this code, we create a simple email spam classifier using Python. The classify email function checks if certain spam keywords, like urgent, money, winner, or lottery, appear in the email text. If two or more of these keywords are found, the email is classified as spam. Otherwise, it is classified as not spam. Here are some strategies to handle multi-class classification problems. First, one versus all or OVA converts the multi-class problem into multiple binary classification problems. Each classifier distinguishes one class from all the others. Second, one versus one or OVO creates binary classifiers for every pair of classes. The final prediction is made through voting among all classifiers. Third, softmax classification directly predicts the probability distribution over all classes. This method is commonly used in neural networks for multi-class problems. Decision boundaries are critical in classification. Let's understand them. Linear boundaries are straight lines that separate classes and are ideal for linearly separable data. They are simple and efficient but can be limited in complex scenarios. Nonlinear boundaries are curved or complex shapes that can capture intricate patterns in data. They are more flexible but require more computational resources. Hyperplanes are boundaries in high-dimensional space. They allow classification based on multiple features simultaneously and are essential for real-world applications. Let's explore some key classification algorithms. First, logistic regression models the probability of binary outcomes. It uses a sigmoid function to map linear predictions to probabilities between 0 and 1. Its key features are that it's simple and interpretable, outputs probability scores, works well for linearly separable data, and offers fast training and prediction. Next, decision trees create a tree-like model of decisions based on feature thresholds. These split data into increasingly homogeneous groups. Decision trees are easy to understand and visualize, handle nonlinear relationships, can model complex decision boundaries, and don't require feature scaling. Let's explore more key classification algorithms. First, support vector machines or SVMs. Find the optimal hyperplane that maximizes the margin between classes in high-dimensional space. SVMs are effective in high dimensions, memory efficient, versatile through kernel functions, and have strong theoretical guarantees. Second, neural networks model complex patterns using interconnected layers of artificial neurons. These learn hierarchical representations of data. Neural networks learn complex patterns, automatically extract features, have a highly flexible architecture, and scale well with data. Let's delve into the evaluation metrics to understand model performance. First, accuracy is the ratio of correct predictions to total predictions. Second, precision is the ratio of correct positive predictions to total positive predictions. Third, recall is the ratio of correct positive predictions to all actual positives. Fourth, the F1 score is the harmonic mean of precision and recall. Let's explore some real-world applications of classification. First, in email filtering, we classify emails as spam or legitimate using text analysis and sender behavior patterns. Second, in image recognition, we identify objects, faces, and scenes in images for security and automation systems. Third, in fraud detection, we detect fraudulent transactions by analyzing spending patterns and user behavior. Fourth, in medical diagnosis, We assist in disease diagnosis through analysis of medical images and patient data. Here are the key takeaways from this discussion on classification in machine learning. Classification is a fundamental task in machine learning that enables systems to categorize data into predefined classes. Different algorithms suit different types of problems, from simple linear classifiers to complex neural networks. Evaluation metrics help us understand model performance and choose the right algorithm for specific use cases. Real-world applications span across industries, from email filtering to medical diagnosis. Finally, choosing the right algorithm depends on data size, complexity, interpretability needs, and computational resources. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.